Hello, in this video we're going to be taking a look at finding the points of intersection between lines in 3 dimensions. So there's two different examples we're going to look at where they do intersect and how to show that is the case, and also how to show when they are not intersecting with each other. And I'm going to timestamp both of those things below so you can skip through to whichever part you want to see. If it is useful, please do like and subscribe. Okay, so let's first take a look at an example where our lines are going to intersect with each other. And you can see here I have this question where it says find the coordinates of the point of intersection of the lines R1 and R2. Now the key thing to remember here is that with our vector equation of a line, the point R1 or R2 is just describing a generic point on our line. And so at the point of intersection, the value of R1 is going to be equal to the value of R2 because it's the same coordinates, isn't it? It's the point of intersection. And so we're going to set our lines equal to each other, okay, and then we're going to try and find a value of lambda and mu that makes the x, y, and z coordinates equal. And we'll see how to do that. So we're going to set these two things equal to each other. We're then going to have a look at what this is saying. So let's look at it bit by bit. So the x coordinate, okay, of our line R1, well, that's given by 6 plus lambda multiplied by -1. So let's write that out. The x coordinate is going to be 6 minus lambda. And we want that to be equal to the x coordinate of our line R2, so 2 plus mu multiplied by 2, so 2 plus 2 mu. We can then do the same for our y coordinate because we also want that to be equal, so we're going to get 1 plus lambda multiplied by 2 for the line R1, so 1 plus 2 lambda. And for our second line, we're going to get 1 plus mu multiplied by -2, and so we're going to get 1 minus 2 mu. And we're going to do the same for the z coordinate, so we get 2 plus lambda is equal to -14 plus 3 mu. Now all this has given us is just a set of simultaneous equations that we want to solve. And so we solve it like normal, so let's label them. We've got equation 1, 2 and 3. And we want to find a value of lambda and mu such that all three of these equations are satisfied, okay? If we can only satisfy two of the equations, then there will not be a point of intersection because we will have only made, say these two equations are satisfied. Well, then we've made the coordinates of x and y equal to each other, but unfortunately we haven't got the same value of z for both equations, and so that's not a point of intersection. You'll see how we check this. So solve them like normal, and to do this I'm going to add equations 1 and 2 together because look, you'll notice I've got plus 2 mu and minus 2 mu, so they will be eliminated. So 1 plus equation 2 is going to give me 7 plus lambda, let me not have two equal signs, 7 plus lambda is going to be equal to 3. And so subtracting 7, I get lambda is equal to -4. Let me now substitute that in to say equation 1, and we get, well, 6 subtract -4 is 10, and that's equal to 2 plus 2 mu. Subtract 2 from both sides, we get 8 is equal to 2 mu, and divide both sides by 2, and we get mu is equal to 4. Okay, so now we have our solutions for lambda and mu, and we know that they work for equations 1 and 2. The final step is to check that these two values satisfy the third equation, and if they do, then the values of x, y, and z in our coordinates will be equal, and therefore we will have a point of intersection. So let's substitute it in, so we get 2 plus, well, minus 4, and we want that to be equal to -14 plus 3 lots of 4. So we get -2 is equal to -14 plus 12, and so we get -2 is equal to, -2, which is true. Therefore, the lines do intersect. Okay, so the coordinates of the intersection, well, let's say substitute in our value of lambda and mu into the first equation, R1. I'm just going to move everything across slightly so I've got a bit more space to write stuff down. So we know lambda is equal to -4, mu is equal to +4. Let's substitute that into R1. So the coordinates of intersection x, y, and z are going to be equal to 6, 1, 2. Well, lambda is -4, so minus 4 lots of -1, 2, 1. Let's now work this out. We've got 6, 1, 2, subtract, let's multiply these together, so plus, let's write it like this, 4, -8, -4, and so the coordinates of intersection are going to be 10, -7, and -2, like so. So that's the first question done. That's when our lines are going to intersect with each other. Let's now have a look at this second case where we have two lines and we want to show that they do not intersect. Now, very quickly as a side note, in 2 dimensions, okay, let me see if I can draw a nice picture here. in 2D, like so, so we've got x and y. Well, say this is one of our lines, this one here, okay? Now, if I draw any other line that is not parallel, so it could look something like this, okay? At some point, they are going to intersect, okay? The only time they do not intersect with each other is if they are both parallel. Now, in 3 dimensions, it is actually possible for lines to not be parallel with each other, but to also never meet, okay? And we call these skew lines. And so lines are skew when we can't find a value of lambda and mu such that R1 equals R2. So let's have a look here where we're trying to show they do not intersect. So R1 equals R2, that's what we would have if they intersect. So let's put these two together and get our simultaneous equations like before. So we bring both of these things down. We're then going to get our equations 2 plus 4 lambda is equal to 5 plus mu. 2 minus 4 lambda is equal to 1 plus mu. 3 plus 6 lambda is equal to 2 plus 3 mu. So equations 1, 2 and 3. What we can do here is do equation, say 1, subtract equation 2, because that's then going to eliminate our mu from both equations 1 and 2. So let's do that. So 1 subtract 2, well, we get 8 lambda is equal to 4, which is going to imply that lambda is equal to 1/2. Let's then substitute that into equation 1. So we're going to get 2 plus 4 lots of 1/2 is equal to 5 plus mu. So we get, well, 4 multiplied by half is 2, so 4 is equal to 5 plus mu. And so -1 is equal to mu. So we have 2 solutions now. We've got mu is equal to -1, lambda is equal to 1/2. We've used equations 1 and 2, so now we need to check that it also satisfies equation 3. So let's do that. Let's put those values into equation 3. So 3 plus 6 lots of 1/2, is that equal to 2 plus 3 lots of -1? Well, we get 3 plus 3 is equal to 2 subtract 3, so 6 does not equal -1, therefore the lines do not intersect. There we go, and that's that done. So hopefully this video was useful. If it was, please do like and subscribe and go over to my channel where I've got loads of other maths tutorials. Thanks for watching.